Rain is the most important source of all water on earth. The water cycle is unique. In an endless cycle, rain rejuvenates all freshwater reserves. Rainwater recharges the surface sources and slowly seeps into the ground to reach and replenish the underground aquifers. The present water crisis is a result of our failure to appreciate this primary source of all water on earth. In the last few decades, rapid urbanization has spread across the country. The population of urban dwellers has risen dramatically. It is expected that by the year 2025, more than 50% of the country's population will live in towns and cities. Because of this population explosion, the demand for water has risen sharply. As summers approach, the demand for water increases, but the supply remains low. Today, most cities in India are facing acute water shortage. Groundwater being accessible with easy-to-extract techniques bears the brunt of the shortage and is today under great stress. Our groundwater levels have declined sharply all over the country. In some aquifers, fresh water is underlain by brackish water. As more and more groundwater is pumped out, the brackish water rises, polluting the fresh water, making it unsuitable for drinking. In coastal areas, there is always a threat of seawater intrusion into freshwater reserves as deeper tube wells are dug to extract more groundwater. Today, we face a serious water crisis because while groundwater continues to be pumped out in huge quantities, very little water is recharged into the aquifers. With rapid urbanization, lakes, ponds, and green areas that contribute to recharge have reduced drastically. Catchment areas have been paved and reclaimed for construction. As a result, even when the rains come, no recharge can take place. Each year, the monsoons bring abundant rainfall to India. India receives an annual average rainfall of 1100 millimeters. But in urban areas, this rainwater is unable to seep into the ground because the land is sealed for miles with concrete buildings and a network of roads. Instead, this precious water gushes out through drains and nalas and flows into the rivers and onto the sea. Billions of liters of fresh water is lost each season this way. The runoff of urban areas is heavily polluted due to an inefficient sewage system and disposed garbage all around. This wastewater flowing along drains seeps underground and pollutes the freshwater aquifers. In low-lying areas, the downpours leave the city waterlogged. Roads get flooded as the natural drainage systems are blocked. The water slowly evaporates and no recharge can take place. In urban areas, the need for rainwater harvesting is critical. Water is already the scarcest commodity. As demand increases further, the situation could spiral out of control. Rainwater harvesting is simply catching rain where it falls and using it for storage or recharging the underground aquifers. Everybody can harvest rain. All that is required is a catchment area, the surface that receives rainfall directly, like the roof of a building, a terrace, or a courtyard. It also needs pipelines and drains. Most houses already have downpipes in place. These carry rainwater to the gutters. It is here that a small change can be made. This change consists of diverting rainwater either to a storage tank or to a recharge structure. Rainwater can be harvested through various structures. The construction of these is dependent on the existing geological conditions of the area. It is therefore important to understand which structure is suitable for which situation. Hilly areas receive suitable for storing rainwater, as the hydrogeological conditions are not conducive for recharge. Water can be harvested by storing rainwater in tanks on the surface or underground. Desert areas receive low rainfall. The water table is very low here. In such areas, it is beneficial to store rainwater in suitable structures, as is practiced in the desert state of Rajasthan. Areas which have a very thick top impervious layer don't allow rainwater to percolate down. These places suffer from frequent waterlogging and are not suitable for recharge structures. Constructing recharge wells would be very expensive here. The best alternative is to build storage tanks. Areas with a top pervious layer are most suitable for direct recharge through structures like recharge pits, trenches, and abandoned wells and tube wells. To build these structures, it is essential that the water table is at least 8 meters below the ground level. The unsaturated zones above the aquifer provide space for storage of water and also allow natural filtration of water percolating down. Earlier, dug wells and tube wells were used to extract groundwater, but many of these have now gone dry because of declining water levels. These abandoned structures can be utilized for recharge after proper cleaning. This helps save the construction cost. In small houses or a campus, rainwater collected from the rooftop or terrace is diverted by downpipes through a filter mesh to a desilting chamber or filtration tank. This tank removes silt and other impurities and also acts as a storage tank for storing excess runoff. From here, this water is diverted to the recharge structure, which may be a pit, trench, abandoned structure, or a combination of these, depending on the requirement. Usually, the front yard of a house slopes into the road. Water therefore flows out. The driveway of the house can be designed in such a way that there is a slight dip in the center, forming a trough. A bore pit or trench dug at this point can absorb the rainwater. In a locality-level water harvesting system like an apartment block, rainwater runoff from individual houses can be harvested in common areas. Colonies should collectively build rainwater harvesting structures so that precious rainwater is not lost to drains and gutters but goes to replenish the aquifer. Millions of liters of rainwater can be harvested in this simple way. During the monsoons, a lot of water accumulates in low-lying areas of gardens, parks and ponds and remains stagnant for long periods. This water can be harvested by making pits or trenches with or without a borewell in the low-lying area. The pit should be filled with filter media such as boulders, gravel and coarse sand in graded form. The borewell must end in the permeable formation. With growing urbanization, paved areas such as roads and parking lots are increasing day by day. These provide a lot of runoff during the rainy season. Along roadsides, storm drains with recharge pits, trenches or shafts can be constructed to recharge the underlying aquifers. This will also ensure that roads don't get waterlogged following heavy showers. A recharge pit is like a soak pit. It is constructed 1 to 2 meters wide and 2 to 3 meters deep. It is backfilled with filter media in graded form. This structure is suitable for small houses, a campus, or for inside a storm drain. A recharge trench is constructed along the boundary of the house or campus, across the slope of the ground. The trench is built half to 1 meters wide and 2 to 20 meters long depending on the requirement. It is backfilled with filter media. In areas which have a thick top impervious layer, rainwater is not able to directly seep into the aquifer. Here, the recharge structure needs to penetrate through this thick layer to reach the pervious layer. For recharging the deeper aquifers, a shallow shaft with recharge well is constructed. The shaft is 2 to 5 meters in diameter and 2 to 4 meters deep. It is backfilled with filter media. Inside the shaft, a recharge well is constructed for recharging the stored water in the shaft. An abandoned well or tube well can also be used to recharge the deeper aquifers after proper desilting. A recharge well is like a normal tube well. It penetrates the impervious layer and ends in the aquifer. A settlement cum storage tank is constructed near the well for desilting of the runoff and storage of excess water. Clear water from the settlement tank is diverted to the recharge well for recharge. In some areas, such as hilly regions, groundwater recharge is not feasible due to the hydrogeological conditions here. But these areas receive heavy rainfall. And the runoff can be stored in tanks for domestic use. For this, runoff is directed from the roof area by a drain pipe to a storage tank. A mesh filter at the mouth of the drain prevents leaves and debris from entering. A first flush device on the downpipe ensures that runoff from the first shower is flushed out, as it may carry pollutants from the air. The water can then be diverted to a charcoal or sand water filter for filtration before storing in the tank. For drinking purposes, this water should be properly chlorinated. Having discussed the various techniques of rainwater harvesting, there are some important things to keep in mind. If available, use abandoned structures like tube wells and dug wells for recharge. In absence of these structures, build recharge pits or trenches. If there is an impervious top layer, then make a borehole in the recharge pit or trench. If the top layer is impervious and the area is large, build a shaft. If the aquifer is even deeper, then build a shaft with a recharge well. In case of rooftop rainwater harvesting using an existing tube well, use an online filter. When the recharge structure is not possible, store rainwater in tanks. There are also some precautions to be taken. Don't divert domestic, sewage or industrial wastewater into the recharge structures. Don't divert highly turbid water into the recharge structures. Periodically clean the filter media. Maintain the recharge structures properly. Don't recharge in areas where the water table is shallow, that is less than 8 meters below the ground level. A collective and united effort is required to make rainwater harvesting a successful effort. If each and every household and locality can practice rainwater harvesting, water will never again be in short supply. Water is precious. Protect it, save it, conserve it, recharge it, recycle it.